so yesterday we did solving with radicals. Today we're going to focus on solving inequalities that have radicals in them. And then we're going to do some real-world application problems. So we're going to go over the steps to solving first, and they're very similar to what we did yesterday. Do you think you know the first blank? Blank the radical term. So we talked yesterday about how the first thing you want to do is well, we want to get it by itself so that we can square it. So we're going to isolate the radical term. That's the very first thing. Okay, and we're going to talk a little bit more when we get down to the examples about why that's important. Now, remember the last time we did radicals, or not radicals, the last time we did inequalities, we had to take into account some different cases. And like we did yesterday, there are different cases for even roots and odd roots. So steps 2 and 3 are going to be for a special type of root. Okay, so step 2 is to set the radicand greater than or equal to 0. When do we have to do this? So let's think about what it means, right? The radicand has to be greater than or equal to 0. When does the radicand have to be positive? For what case only? Well, yes, the square roots and the even roots, exactly. So steps 2 and 3 are only for even roots. Okay? So the radicand has to be positive for even roots only. And that's because you can take the cube root of a negative. And that's because if you have an odd amount of negatives, okay, it multiplies to a negative. But if you have an even amount of negatives, anytime you have an even amount of negatives and you're multiplying, it results in a positive. Okay, so this step we just talked about it. Consider the radicand. When does it always have to be greater than or equal to 0? Okay, when you have even roots. Okay. And I use the square root for a shorthand instead of writing out even root again. Okay, but it has to be greater than or equal to 0 only when you have an even root, because that's when you can't take the root of a negative. With odds, it's okay. So when would we not have to do step 2? Yeah, when there's an odd root. So for odd roots, you do not have to do step 2. That's very similar to what we did yesterday, right? Because what didn't we have to do yesterday if it was odd? Yeah, we didn't have to do the check if it was odd because there's no extraneous solutions. Okay? So the last thing we're going to do, step 3, it says find where the solutions in step 1 and step 2 overlap. That's really similar to something that we did. Right? Do you guys remember how I had you find the overlap? What did we use to help us? Yeah, use the number line. Okay, that visual is very powerful. It's very easy to see where the overlap is if you do your number line. Okay, so example 1, it's just going to say to solve. We're going to solve using algebra. So step 1 is to isolate the radical term. Okay? Now the reason why you want to isolate instead of just jumping in and squaring both sides, you don't have to write this part down, okay? I just want to show you why we have to isolate the variable. if you jumped in and you squared both sides, okay, on this side, remember, this squared means you would have to write this out and multiply it, which is something that you'll do next year. Okay, so you guys want a little preview? That's what we are going to do. I'm showing you why we're doing it, to avoid this chaos. So to simplify this, you could simplify it. What's the square root of 2 minus 2x minus 6 times itself? Yes. Now, on the inside, you would get 3 times the square root. On the outside, you get 3 times the square root. So this would end up being 6 times the square root. And then 3 times 3 would be 9. And then you'd have to simplify. You'd have to get your like terms. You'd have to end up squaring again. See how it would be a lot of work? Yeah. So when you do this next year, it won't be with inequalities. You'll be solving. It'll be a little bit easier. So in order to avoid that drama, we're just going to subtract the 3 over. Okay, and then this is the same as yesterday. So to undo the root, what do we do to both sides? Yeah. Okay, and then we're going to add 6. We're going to get the x by itself. And your final step is to do what? Divide by 2. Now, you do have to remember, if you divide by a negative, what has to happen? If the sign flips. That's not happening here, so yay, but you might see one of those on your homework, okay? Okay, so that's step 1. Now, is this an even root? Yes, if it's an even root, we have to do step 2, okay, which is just taking the radicand, that number underneath the radical, setting it greater than or equal to 0. So it's only what's underneath the radical. It's only that 2x minus 6. And I feel like you guys can solve things like this pretty quickly. Do you guys agree? Move the 6 over. And I'm even fine if you're just doing it like this, where you have the steps written out. Okay? Now, the last thing you want to do is find where these two overlap. So step 3, you want to find the overlap between your two solutions. So when you use your number line, the way the number line works is you do have to put these in the correct order. So least to greatest, x is greater than or equal to 3, means you have a closed circle and it's going to the right. X is less than or equal to 21. And then the overlap is going to be your solution. Are you guys pretty confident about writing this as a solution? So you're going to start where the overlap is, which is at what number? 3. Okay, so we're going to start at 3. And then because it's a closed circle, you have less than or equal to x. And then that would be less than or equal to 21. Okay, if there wasn't an overlap between them, do you guys know what you would write for your solution? No solution. No overlap means you would have no solution. Not for this, because what you have to do for these is you have to find where these two both come together, because both have to be true. But in the other cases that we did, where we did the positive and negative case, yes, you could have a or situation. Yep. All right, and then for B, this is an odd root. All right, and then what's my first step? What do I want to do to both sides? Yeah, good. You're doing a good job with the terminology as well. What is 1 cubed? 1. And then I'm just going to subtract 2. And then if it's an odd root, do we have to do step 2 and 3? Nope, it's only for even roots. So because it's an odd root, you are done. Okay, if it's an odd root, you don't have to worry about the radicand. It can be positive or negative. Okay, so odd roots, you do not have to do those extra steps. Okay, now, why don't you try step 3 and then check in with your row. Oh, yeah. That's one person that is she has one. And then will you check in with your partner and make sure that you got the same thing? All right, you can check in with me for your step 1. How'd we do? X is less than or equal to 12. And then the even root means we're doing step 2. So you only have to take what's underneath. So it's that x minus 3, which is greater than or equal to 0. It has to be greater than or equal to. I just noticed that all these are greater than or equal to. Sometimes this could just be a less than. And if that happens, you could have 2 different symbols in there. That would be fine. But you guys will have some time to practice today. Okay, and then we're going to see where our overlap is. So again, when you're doing the number line, you have your numbers in the correct order. Both of these are equal to. So x is greater than or equal to 3. X is less than or equal to 12. Your overlap is right in the middle there. So then your solution is 3 is less than or equal to x, which is less than or equal to 12. Okay, you can also look at these and see they both happened. They can both happen at the same time. There are several numbers that are greater than or equal to 3 that are less than 12. So you are putting those 2 together. Okay, and then if they can't happen at the same time, that's when you would have no solution. Okay? All right, now we are going to do our applications. Okay? So we're going to read through this story problem. It says the time t in seconds. So anytime there's a variable, I like to just highlight that, the time t in seconds. And that it takes a car to travel a quarter mile when starting from a full stop can be estimated by using this formula. So that's going to be important. I'm just going to box that in. And then W is the weight of the car in pounds. And then P is the power delivered by the engine in horsepower. Are any of you guys big into cars? You know things about horsepower?
I got a boat.
You got a what?
A boat.
That's got horsepower? You know how many horsepower the boat is? Oh, okay. So if the quarter mile time for a 390-pound car is 13.4 seconds, okay, how much power does its engine deliver? And then we want to round to the nearest horsepower, which means in this case the nearest horsepower is just going to be the nearest whole number. That's the nearest horsepower. Okay, so if I were reading this in my textbook, right, writing in there. So the first thing I would want to do is organize my information. So what's the first thing that you guys notice when you're reading a story problem? You probably sometimes just go right to it. When you're reading a story problem, is there anything that you notice first? The formula, right? So if this were a problem in my textbook, I would be writing out the formula first. Okay, and then another thing I do sometimes, especially if I'm doing like a SAT type of test where I'm trying to understand and process what's going on in this problem, I would start organizing things because I don't like to waste time. Sometimes I can read things over and over again and it's still not clicking. So for me, writing some of the stuff out is helpful. So saying what the variables are, like the T is the time in seconds, and it takes a car to travel the quarter mile. That is really just extra information that's not going to factor into our problem solving. Okay, so I'm just going back over. W is the weight, and that's measured in pounds. And then P is the power in horsepower. Okay, so I'm not really familiar working with horsepower a lot, so for me, organizing that and labeling what the P is equal to, that helps me. Okay? All right. Now, when you're solving this, okay, there's a couple different ways you can solve it. A lot of you would just jump to the evaluate portion because they give you the pound of the car, they give you the weight is the 3590 pounds, and they give you the time is the 13.4 seconds, and you can absolutely do that. You can plug it in and you can solve it. But one of the things that we're going to practice in this section is solving a formula for a variable. And so we're going to do step 2 together and then do step 3. So just to repeat that, the reason why I'm going to solve the equation first is some of your problems in this section are only going to be about solving the equation. Okay, so we're going to practice what that looks like when you have some more complex formulas. So we're going to solve the equation in terms of P, which means you want to get P by itself. So I'm going to start with T equals 5.825. The cube root of W over P. Okay, so you're going to isolate this variable. So basically, we just have to move everything else over until we get P is equal to a value. Okay? So what are you guys thinking? What should we do first, you think? Okay, we do want to move this number over first, but think about how these two are connected. Yeah, they're connected with multiplication, so we're going to divide. Yep, so we're going to just divide both sides by 5.825. So when you divide, those cancel, and you'll get the cube root of W over P. And then we're just going to leave this right now as T over 5.825. We're not going to, well, you really can't do any calculations with that. Okay, so what should we do next? What's our next layer that has to be moved over? Yeah?
I would keep both sides.
Yes, great. So now we're going to cube both sides. Now when you cube a fraction, remember you can apply it to the top, which would be T cubed. And then we aren't going to calculate that right now. I want to keep this as simple as possible for the time being. And now I have W over P. Notice that you have a fraction equal to another fraction. You guys studied equations like this in geometry. Do you guys remember what it's called? It starts with a P. Yes, proportion. Good. Okay, so whenever you have a proportion, you're going to cross multiply. And that really is going to be the simplest thing, because you could multiply both sides by p, and then you'd have to divide by the fraction or multiply by the reciprocal. So cross multiplying is going to be your simplest bet here. Do we remember how to cross multiply? Okay, so t cubed gets multiplied by what? Yes. Okay, and then 5.825 cubed is multiplied by the w. All right, just one more step. What is it? Yep. So to get p by itself, we're just going to divide both sides by t cubed, and we're just going to write what p would be. So 5.825 cubed times w divided by t cubed. Okay, so again, some problems in your homework are only going to ask you for that. They're going to give you a formula, and you're going to have to just solve it for a variable. You won't even have to do an evaluation piece. Okay, for this one you do have an evaluation piece, so we're going to just substitute in. We have the 5.825 cubed multiplied by w, which is the 3590 pounds that we already wrote down, and then the 13.4 to the third. So I'm going to give you a minute to calculate. Remember, you're rounding to the nearest horsepower. I do want you to check in with the person next to you to make sure that you guys rounded correctly, that you got the correct calculation. Make sure you charge them up because you got your test next week. Make sure for your SAT stuff that you have it charged up, and I would bring a backup one. Like if you have a scientific one from the geometry days when you're doing the SAT stuff, okay?
When is that?
Either March or April.
Oh my God. Well, Saint, you actually have to take the SAT.
I believe so, but I'm not 100% sure. But I'll know by Monday. Okay, so this is what I got. Did you guys get the same thing?
Yeah.
Okay, so what did you round to?
295.
Good. And really the only thing that matters is if you're rounding to the whole number, the one right after it. So 295, and then this is in horsepower. So, Dane, it's about the same as the boat you're talking about.
But for a big truck, that's slow.
Yeah, somebody last hour said, yeah, it's about an average horsepower.
You're gonna have a big horsepower.
Yeah. So, like, could you compare that to a car that we would know or no? It's okay if you can't. I don't have a good frame of reference for that.
I don't know. How about like a Dodge Charger?
Okay. All right. Now, for example 3, this is what I was telling you about. How you're gonna solve the following for H. I said yes. You need to show your work, which must have been somebody must have been giving me sass about not showing your work. So yes, you do need to show your steps. Okay. So the whole thing about this is showing how you're getting to the equation, what operations you're performing. So we have D equals the square root of L squared plus W squared plus H squared, which you may have done that in geometry. It was, D is for the diagonal, and then you guys know LWH is.
Length, width, height.
Yes. Okay? All right, so what do you guys think? What's the first thing when we're solving for H? Yeah, good. Square both sides. Say it again. No, but that's something we are going to talk about. That's a good thing to wonder about. Did you take the square root of each one? Yeah. So I'm glad that you guys are thinking about the simplification process. This just goes back. The simplest way I can prove this to you is when you have the square root of 16 plus 9, right? Okay, if I were to split this up into the square root of 16 plus the square root of 9, that would be similar to like taking the square root of both of those, right? But what's the square root of 16? 4. What's the square root of 9?
3.
Okay, so then this would result in 7. But 16 plus 9 is equal to what? 25. And what's the square root of 25? Okay, so this is not valid. Okay, so you can only do that when you are multiplying. Yes. Okay? That's just over. Okay, now to get H squared, how can you move over these two? Subtract. And those, because you're doing the subtraction, you can do that in the same step where you're subtracting. So you get D squared minus L squared minus W squared equals H squared. And then again, just make sure you show your last step. So to get H by itself, what are we going to end up doing? Yeah. Okay, so then your final answer is H equals the square root of. Now, make sure that you put everything under the square root. The reason why I'm saying that is sometimes we make our square root and we make it too short, and then we don't extend it. Make sure everything fits under that square root that needs to be underneath it, okay? All right, and then I'm going to give you plenty of time to do your homework today. And but before you get started on the homework, we're going to look at just a couple things from 5-6. I just want to review a couple things because your test next week is over all of chapter 5. And as I'm working on grading the test, I'm almost done, but I still need, I'm going to need the weekend to finish them. I've been noticing a couple of things that I want to make sure we tighten up before the test, and you'll see them again on your test. Okay, so 5.6 notes, I want you to go to page 2.